So today we are going to start Unit 4. Unit 4 will take us all the way through up until winter break. Okay? And so we're going to put the fun in functions in this unit. Okay? Because we're going to talk about rational functions. Our goal this unit is to graph rational functions. That's what our goal is for right now. We can also simplify rational functions. Okay? And but we won't get to that probably until the end of the year, and we'll talk about that if we got some time left over at the end of the year. Okay, all right, all right. So let's talk first. Come on, there we go. Let's first talk about a rational number. We just got done dealing with some rational numbers. Okay? So a rational number is any number that can be written in the form of a fraction. Okay? So some examples: 2/3, -7/2, 8. 8 is a fraction. That's a bad 8. 8 is a rational number because 8 can be written as 8/1, or 16/2, or 24/3, etc. Any whole number is rational because we can always write it over 1. Yes. Okay. 2.5 is a rational number because we can write it as 5/2. Okay? So those are all rational numbers. Okay? What we're going to focus in this unit is we're going to focus in on rational functions. Okay? A rational function is a function. There we go. Pushing down too hard. A rational function is a function that can be written as a fraction, where p of x over q of x, p and q are both polynomials. And, this is the kicker, q of x is not the 0 polynomial. Okay? So q of x can't be equal to 0 because we can't divide by 0. Okay? So that's what that's saying right there, is this q of x can't equal 0. But some examples of rational functions would be 1/x. That's a function. Or a rational function, I should say. 2x minus 5 over x squared plus 4. That's a rational function. Okay? Just pulling numbers up. Like that one. Nope, that was me exhaling while I was thinking of numbers. Okay? So those are all rational functions. Okay? Now, the first aspect of rational functions that we're going to explore is the domain. What numbers can we put in? Remember, domain is the input numbers. Okay? So what numbers can we put into our function? Okay? So the domain of a rational function includes all real numbers except x values, which make the denominator 0. So the domain, we're going to use capital D for domain. Okay? So the domain is going to be all real numbers, and that's the symbol for all real numbers. Kind of a double vertical barred R. Okay? All real numbers. And then you're going to have a comma, and after that comma, you're going to have some exceptions. Now, you could have one exception, you could have 2 exceptions, you could have 17 exceptions. However many numbers that make your denominator be 0, that's how many exceptions you're going to have. Okay? So, what happens where those denominators make, or where that denominator makes it be 0? Let's use this function. F of x equals 7 over x minus 2. Okay? So the very first thing that we are going to do in most of our problems is we are going to set the denominator equal to 0 and solve. Okay? So in this case, we would say x minus 2, we would set it equal to 0, we'd add 2 to both sides, and we'd get x equals 2. So this is that exception. So the question that we have to ask ourselves is, so what happens with our function when x is 2? That's the question. And the answer is we get something, actually tap the brake. So if we were doing domain here, we would have the domain would be all real numbers, but x cannot equal 2. Okay, so that's our domain. But at x equals 2, we get something called a vertical asymptote. Okay. Let's talk a little bit about those vertical asymptotes. Okay. So first off, a vertical asymptote is a line. So it needs to be in line form whenever we're talking about it. Okay? So, but it's a line that the function cannot cross. It's kind of like a boundary. Okay? It's a big wall. Okay? That function cannot cross it. Okay? If you watch Game of Thrones at some point in time in your lives, okay? It's the wall, okay? Up north, okay? Up by Winterfell. Okay? Nothing can cross that line. That looks like a bad cross. When we get to graphing, which we will get to graphing on Thursday, it will be a dashed line and it must be on the graph. We find it with the restrictions. Of the domain. As I said before, it is a line. Since it's a vertical line, it will always be of the form x equals some number. That will always be the form of your vertical asymptote. So back here, if we go back to this example, we would have a vertical asymptote of x equals 2. Not just 2. 2 is a number. Okay? X equals 2 is a line. Okay? And the last thing about vertical asymptotes, we can have more than one. We can have as many as the degree, well, I shouldn't say that. You will have whatever the degree of your denominator is, that's how many vertical asymptotes you'll have, because that's how many zeros that polynomial has. Okay? So all that stuff that we just did in Unit 3, it's coming back for us. Okay? So what I would like you to do now is I'd like you to get out that separate sheet that I had. Okay? At the very top of that separate sheet, I want you to put down steps to graphing a rational function. Okay? Right at the very top. This is going to be your cheat sheet for all of Unit 4. Okay? And really, it's going to be the start of your finals cheat sheet too, your note sheet for your final. Okay? So steps to graphing a rational function. In the end, we're going to have 8 steps, 8 total steps. Okay? You're going to save some space right here for step 0. So skip down 2 or 3 lines-ish. Step 0 is actually pretty straightforward. We're just not ready for it quite yet. So we're going to save some room for that, and we're going to come back later on, and we'll fill that in. So then we're going to do step 1. The first thing that we're going to do with all of our functions is we are going to find the domain and any vertical asymptotes. How do we do that? We set the denominator equal to 0 and solve. So that's step 1. We find any and all vertical asymptotes by finding the domain of our function. Good? Yeah. Back into your notes now, so keep that sheet off to the side because that's going to be your guide. So from every day from now on while you're in class or when you're watching a video, that sheet should be right next to your notes. Okay? Because that we're going to follow along with that. We're going to add to it, and we're going to do very well with using that sheet. Okay? So we're back in the notes now. The question is, find the domain at vertical asymptotes for this function. Okay? Well, we take our function and we look at the denominator. The denominator is 2x minus 5. We set that equal to 0 and we solve that. First off, I would add 5. That would give me 2x equals 5. Then I would divide both sides by 2. And I'd get x equals 5 halves. So the domain of my function is all real numbers, but x cannot be equal to 5 halves, because that's my restriction. But that tells me then I have a vertical asymptote at x equals 5 halves. Agree? Okay. It's just that easy. Okay. For that step number 1, which is why it's step number 1. It'll get a little more complicated as we go along, but if you keep breaking it down, that's really as hard as it gets. Okay? All right? So, now, before we keep going on with this awesomeness, let's take a quick pause here to talk a little bit about fraction logic. Okay? So we've got a fraction, number divided by number. Okay? So we're talking rational numbers here. Okay? So if I have some number, I don't even care what that number is, but I divide that by a bigger number. For instance, 4 divided by 7, or 4 divided by 700, or 4 divided by 7,000. Okay? As that number on the bottom keeps getting bigger and bigger and bigger, what happens to the value of that fraction? Four divided by 7 is like 0.6. 4 divided by 70 is like 0.06. 4 divided by 700 is like 0.006. 4 divided by 7,000 is 0.0006. What do I got here? 7 million. 4 divided by 7 million is 0.000006. What's happening with that number? It's getting smaller and smaller and smaller. Will it ever get will it ever become negative? No, so it'll always stay positive. So what's the barrier between positive numbers, as we get smaller and smaller and smaller, and negative numbers? 0. Yep, exactly. So this is going to become a really small number the bigger that denominator gets. So as this function, we started up here at 4, as we send this number to infinity, we keep getting it bigger and bigger and bigger, this fraction is going to go to 0. It's going to get so close to 0 that it's going to be like 0. Okay? That's fractional logic right there. Now, instead of making it be a big number, let's switch colors here. Let's make it be a small number. Like, I don't know, 0.1. Actually, here, let me put it in fraction form. 4 divided by 1/10. Okay? So 4 divided by 1/10 is going to be 40. 4 divided by 100 is going to be 400. 4 divided by 1,000 is going to be 4,000. And so on and so forth. See where this is going? What's happening to this number? It gets huge, right? Yeah, the denominator is getting smaller and smaller, but the actual value of that fraction is getting ginormous. Okay? It's getting to be a big number. So as we send this number to 0, we're actually going to infinity. Okay? And beyond. Yep.
Now I understand. Without the, it doesn't make sense.
Gotcha. Yep. Pick it up at 23 minutes. Okay. All right.
She's actually remember that.
No, she won't remember a thing with that. Yeah. So what I mean by that is, or why we have to do that, is because we are going to have to use that fractional logic here when we do problems like this. Okay? Find the domain, vertical asymptotes, and use logic to describe the asymptote behavior. That's what the function is doing near the asymptote, and the end behavior. You right now can find me the domain and the vertical asymptotes. Okay? Go for it. Try it out. Find me the domain, find me the vertical asymptotes. So you should have a domain of all real numbers, but x cannot be 0. And your vertical asymptote should then just be x equals 0. Agree? Okay? Alright? Then it asked us to use logic to describe asymptotal behavior. So the asymptotal behavior, we've got an asymptote at x equals 0. We need to figure out what the function is doing as I come from the left towards x equals 0 and as I come from the right towards 0. So we need to figure that out. So we need to get closer and closer to 0 on both sides. Well, if I'm over here on the left side, I'm negative, right? Okay. So I would be like negative 0.1, let's say. That's pretty close to 0. Okay. So my graph, or the value of my function, would be 1 divided by negative 0.1. Which is what? 10? Negative 10, right? Okay. But we can get even closer. Let's go with negative 100th. That's going to be 1 divided by negative 0.1. That's going to be negative 100. If I got closer, where would my function be going to? If I went to negative 1,000, I'd be at negative 1,000 for the value of my function, right? So my function is actually shooting way down, right? It's going to negative infinity. Because these numbers are getting smaller and smaller and smaller. Okay? So how we write that is as x approaches 0 from the left. Okay? That little negative sign in the exponent is telling you that you are approaching from the left. My function, f of x, is going to negative infinity. Now, that negative sign there is extremely important because it tells you which side of the asymptote that you're on. Okay? So as 0, and we read it as x approaches 0 from the left, f of x approaches negative infinity. Okay? Flip over to the other side. So now, let's go with 0.1, because we're on the positive side of 0 now. So my function would be 1 over 0.1. Well, that would just be 10. 0.01 is even closer. That would be 1 over 0.01. It would be 100. Where's that one going? It's going up, right? On this side, it's going up. So that's going to, I don't know, skyrocketing into infinity, right? Okay. So as x is going to 0 from the right now, because now I'm on the right side of 0, f of x is approaching positive infinity. Okay. Then one last thing we've got to find, and that is we've got to find our end behavior. So our end behavior is going to be as x approaches positive infinity, our function is going to be approaching something, and as x approaches negative infinity, our function is going to do something. Okay. Well, out here at x equals positive infinity, I'd have a really huge number, right? Positive infinity is a really huge number. So I would have 1 over a positive, huge number. What's that going to be? If I was at 1,000, I'd be 1 over 1,000. If I was at 1,000,000, I'd be 1 over 1,000,000. Nope. What kind of small number? What did we say in our fraction logic? What was the number that it goes to? A number divided by a huge number is going to go to 0. Yeah, so this is going to go to 0 over here. Come back to me. So this is going to go to 0. And because it's positive, because positive 1 is divided by a positive number, it's going to approach 0 from above. Okay. And lastly, way over here, oops, let me use a different color. Let's use, okay, I'm going to use green yet. Over here at x equals negative infinity, over here at x equals negative infinity, now I'm going to have 1 over a negative huge number. So what's that going to do? Not go to infinity, because 1 over here went to 0, right? So it would go to 0, but from on the negative side, right? So that would be 0 from below. Okay. When it's attached to the x, that plus or minus tells you left and right. When it's attached to the function, that tells you above or below. Yeah? And that's the 6 answers that we were asking for out of this. Whoa, that breaks a long time with it. Cool. Yes. All right. Now, you can do the first problem on the worksheet for this week. If you're at home, again, you'll have to print it off for this week. If you are here in class, I'm handing out the entire unit's homework packet so that it's said and done. I was overambitious last week. Yeah. So you got that going for you, which is good. Okay. So as you can see for this week, one homework problem a day, basically, is all I'm asking you to do. Okay? I think you can handle that. Tomorrow there will be a video for you to watch. Please watch it. It'll be posted on It's Learning this afternoon. Okay? And then you'll be able to do the next one. Okay?